Welcome back to our website of Type Talks. So we are going to move on again with more examples on a scenario where the denominator has got a quadratic factor. And I said in your mind that a quadratic factor which cannot be factorized, which has no factors. So we move like this example goes: express 5x squared minus 10x plus 11 all over x minus 3 into x squared plus 1 in partial fractions. So what we're going to do, we are going to say let 5x squared minus 10x plus 11 all over x minus 3 into x squared plus 1, the same as, this one is linear, we shall say a out of x minus 3 plus, this one cannot be factorized, we are going to say bx plus 3 out of x squared plus 1. So what we're going to do is this. We are having 5x squared minus 10x plus 11 all over x minus 3 into x squared plus 1 is the same as, we get the LCM. So the LCM is x minus 3 into x squared plus 1. The whole of this one divided by this, I'm remaining with a into x squared plus 1, then plus bx plus 3 into x minus 3. Since the LCM are the same, the denominators have got the same value, they cross. So we are remaining with only the numerators, which is 5x squared minus 10x plus 11 is the same as a into x squared plus 1 plus bx plus 3 into x minus 3. So what we're going to do is this. Can we try to use the, for equating the coefficients? I'm going to open up the brackets. This is the same as ax squared plus a plus bx times x. We are getting the bx squared minus 3bx, then plus cx minus 3c. So we go ahead and we collect terms, those ones with x squared. We are having ax squared plus bx squared minus 3bx plus cx plus a minus 3c. The whole thing equals 5x squared minus 10x plus 11. So we are having 5x squared minus 10x plus 11 is the same as, we are going to have a plus b x squared plus negative 3b plus c into x plus a minus 3c. So we are going to say equating monomials, of same coefficients, So I want to look at those ones which bears the same coefficients, which are in the left hand side together with those ones in the right hand side. So when we start dealing with the one of x squared, we have got a plus b equals 5. I say this is the first. We got those ones of x, we have got negative 3b plus c equals negative 10. This is the second. Then another one is a minus 3c equals 11. This is the third. So what we're going to do, we are going to look at how can we deal, which numbers have got related values, and we solve them simultaneously. So I can see the first one is having a constant, a known of a and b, and this one is negative b and that, this and this. So what am I going to do? If I deal with, if I can eliminate b from one of the equations, or if I can eliminate c. So what I'm going to do is, I'm going to deal with 1 and 2 simultaneously. I will say solving 1 and 2. So we have got a plus b equals a 5. Then another one is negative 3b plus a c equals negative 10. So what do? We are going to eliminate. I'm going to put a 3 up then a 1 down. 3 times A, I'm having 3A plus 3B equals 15. I remain with negative 3B, then negative 3B. No, my interest is to eliminate what? Yes, negative 3B plus a C equals a negative 10. How can I eliminate a B? By adding. What if I add? When I add B and B disappears, I remain with 3A plus a C equals 15 plus that, I'm getting a 5. I can call this is equation 4. Now you can see equation 4 is related with equation 3. Then I say solving 3 and 4 simultaneously. So once solve those two equations. So equation 3 is having A minus 3C equals 11. Then another one is having 3A plus a C equals 5. I can eliminate A. I put a 3 up, then 1 down. I multiply throughout. 3 times A, I'm getting 3A minus 9C equals 33. When you multiply by 3 throughout, 1 times 3A, I'm getting 3A plus a C equals 5. What can I do? I just subtract. Can we subtract the 2? This 3A minus 3A disappears. Negative 9C minus a C, I'm getting a negative 10C equals 33 minus a 5. 33 minus a 5, you are getting automatically a 28. So we are coming out with a 28. We are coming out with 28. So can we guide, and now we divide out by negative 10. C alone can reduce even by 5. So I'm going to get negative 14 out of 5. That is the value of C. After coming out with that one as a value of C, so again we go ahead and we deal with, as we have got the value of C, we can substitute in N to obtain the value of A. Can say put C equals negative 14 out of 5 in equation 4. What was equation 4 saying? 3A plus a C was equal to 5. So where I see a C, I bring that stuff. I say 3A minus 14 out of 5 equals a 5. So maybe I can multiply out by 5 throughout. I get 15A minus 14 equals 25. Take this one the other side. We're remaining with 15A equals a 39. Divided by 15. So what is A alone? A equals 39 out of 15. That's our constant A. Now we have already got A. We are free to substitute in any equation, like equation 1, to get the value of B. I can say put A equals 39 out of 15 in equation 1. What was equation 1 saying? Equation 1 was saying A plus B was equal to a 5. So do we know the value of A is already 39 out of 15 plus B equals a 5. So can we make B alone? So B is the same as 5 minus 39 out of 15. So when we get the LCM, C remains as 15. Then we are going to multiply that 15 times a 5. When you try to solve 15 times 5, we are getting 25, right? A 5. Then this is a 5 plus a 2, we are getting 75 minus 39 out of 15. So can we subtract 75 minus 39? What are we getting? 75 minus 39. So we are coming out with 36 out of 15. So we are getting 36 out of 15. Can a 3 go there? A 3 can go there. can go there. How many times? That is 12 times. We say by 3, that is 12 out of 5. So I've tried to reduce it up to its maximum point. Then after getting all those constants, then you are free to come and substitute in. Where you see the value of a, you substitute in to obtain a clear partial fraction. So how does it move? This is the same as, what is the value of a? The value of a is already given as 39 out of 15. We said we write as 39 out of 15 into x minus 3. We come plus, what is the value of b? Is already 12 out of 5, which is the same as 12x. And the value, see, all of them, they have the same denominator. We say minus 14 all over 5 into x squared plus 1. So therefore, 5x squared minus 10x plus 11 all over x minus 3 into x squared plus 1 is the same as 39 out of 15 into x minus 3. But even still, you can reduce. 3 can go in 39. If we try to reduce, can 3 go in 39? How many times does it go there? 13 times. When you say that is 13, can reduce and say 13 out of, by 3, this is already 5 into that, then plus 12x minus 14 all over 5 into x squared plus 1. You have already tried to express in the required partial fraction, having or bearing in mind that the denominator is consisting of a quadratic factor which cannot be factorized.